Moving on, bringing Jon Nortier. He's a mining engineer with over 20 years experience in operations and technical studies. He leads the open pit planning team at AMC here in Perth, and is always looking for smarter ways to tackle complex challenges. Outside of work, Jon has recently mastered pigtails for his 2-year-old daughter and rebuilt his kitchen. I think that's a skill that, yeah, that's amazing. So if you've got questions about mine planning, plywood, cabinetry, or taller hairdos, that's the guy. Welcome, welcome, Jonathan.
All right, morning everyone, and thanks for the opportunity for talking today. Recently, I've really been getting into waste dumps, or looking at options for integrated waste landform in MineMax. Look, often waste dumps are left to later in the study, or forgotten about, and maybe it's up to the site team to sort of work out how they're going to come together, or even at worst, operations trying to figure out where's this PAF going to go next week. All the naffs in the bottom of the waste dump, and now we've got nothing to put on top. So why not bring it into your strategic mine planning? We've got the tools, and yeah, you can start to make some of those decisions a bit early on and avoid some of the strife down the track. So today I'll just touch on the why, a few terms, some approaches. I've got a few case studies to touch on, and then we'll wrap it up. So why integrate waste? So you can have a look at your strategic waste placement. So you can sort of have a bit more of a think about where certain materials are going to go and why they might go there and the timing. Evaluate multiple scenarios. You might have a mine sustainability or closure plan you need to adhere to, so you can start having a bit of a think about how you're going to approach that. Quantify the value impact. So often we might just look at the mine and the plant and maybe some capital in isolation, make some decisions, but without the waste dump, you might not truly understand the impact on value. Often haulage is around 30% of your costs for the mining operation. So it's a big spend, and a lot of that comes to where you might be placing it. Assess the resources needed. So if you've got a lot of long hauls at the end of the mine life, you might have to start purchasing trucks later. You might be able to spread that out if that's something you're interested in, but at least you understand what the impact is going to be on your haulage fleet if you've got it integrated. Expose bottlenecks. So I mentioned PAF and NAF before. Often if you've got a more detailed encapsulation system, you might need to start managing your materials and how you're going to deal with that. So find out where your crunch points are going to be in your strategic plan so you can get ready for that. And that sort of leads to operational readiness. You might have clay liners or cover systems. You might need other sort of services on site to help you deliver your waste. TSF embankment construction, we've done many studies recently with people using waste material for the bulk of their TSFs. So you can integrate that into your plan as well. Make sure you've got enough waste to keep ahead of the plant, as well as integrating that with the capital decision making. So integrate your waste. You can avoid sort of having to make really quick decisions later on, and you can just think about it strategically. Couple of terms I use, so ARD, acid rock drainage, PAFs, potentially acid forming material, NAFs, non-acid forming material, and NAP is the net acid production potential. That photo there was a personal shot I took of one particular site with some really nasty material that, if left for a number of days, would start to spontaneously combust. So that there's sometimes some very important reasons why we might want to be looking at this sort of holistically and how you can encapsulate that. I'm not a geochemist, but so we sort of utilize their information to integrate it. So yeah, it's important we sort of understand the terms that they're using, and we understand the data that they're providing us so we can integrate it. So approaches. So like anything in mine planning, it depends. What level of at the study, are you at the concept? Are you at the DFS sort of stage? How much information do you have? What's in your block model? So often you might not consider your waste dumps early in your mine life because you just don't have a lot of information. You haven't done your geochem, you haven't done your waste characterization, but you might have a bit of an inkling. You might have sulfur in your model, you might have a lithology model, or you might just be basing it on oxide and sulfides and sort of get a rough idea. Dump design complexity. So Some operations need a very complex cover system for their waste dumps to encapsulate the nastier material, or it might be very simple. You might also be very early in your mine life. You don't really know what it is, but you understand you're probably going to need something to sit on top of it or layer it or create a base. Does your site have stockpiling capacity? So one operation we've worked with just zero stockpiling capacity for anything. So all the NAF that's needed needs to be mined as you're going over the operation. So you can't sort of just sit there and wait for later. And modelling constraints. So we sort of talked a bit before about blending for grades, for throughputs. You can also apply your constraints to your waste dump. So that can be for the NAP we talked about before, or proportions of PAF and NAF as it's coming out by dump, by lift. So we'll just touch on a couple of case studies. So I suppose the case studies go from more maybe high level data to more detailed sort of towards the end of your sort of study period. So for this particular one here, just a very basic NAF-PAF definition based on the weathering profile. So oxide is NAF, the sulfides are PAF. We had a few different X pits, a few in pits, so you can be trading off those. The X pits had a sort of a concept cover system, and the in pit was going to be a different method and didn't need any sort of ratio constraints. There was a stockpile available. All these ones we have integrated haulage, so we can sort of model the truck hours required and constrain that if we want to. So the current X-pit dump design involved a layer of NAF on top of each sort of PAF and then an outer face of NAF. So we designed that up, some concepts using Studio P, work out some rough ratios and go, for this particular dump, we need 20% NAF. For this particular dump, we need 10% NAF. So there's a whole bunch of modelling considerations. I suppose the primary one with MineMax is if you want to define your waste types differently, you need to bin them differently. You need to model them differently so it can allow different materials to go different places. You need to add some splits into your process flow to go to different dumps and manage for different materials. Need to map some processes that align with your reblock, create constraints on your dump processes so you can start limiting material, define some stockpiles. And then on the constraints, you got some dump precedences, so you got that spatial compliance and stockpile capacity limits and a proportion limit. So this is a stylized decision tree. So we had a number of X-pit dumps, a number of in-pit dumps. And so the similar flow, if you've used the dumping tool with MineMax, you can sort of manage the volumes and then manage your truck hours underneath. And for this particular one here, we've got the NAF constraint off to the side where we can assign an attribute to that particular process. And so we can limit what material's going there. So you set your constraints. So we've got dump 1 and 2 with a NAF ox percentage up there at 20%, and then 10% for dump 2, and then a stockpile limit of 8 million for the NAF oxide. So we can see here early in the mine life, we're mining the oxide zone. We've got a lot of excess NAF. It's easy to achieve the proportions on the dump. But longer term, we're right on that limit. So the schedule is having to adjust how it's mining to hit that percentage of NAF required for that particular dump. And you can test by turning it off, turning it on, understand what the value is. You get all the usual outputs, a total movement here. I'll just point you to the orange thing. So that's the small amount of NAF stockpile rehandle that's required for this one. So it's not needing too much. A lot of it can be managed from hand to mouth. To avoid any stockpiling costs or rehandle costs. Base mining, you get your sort of proportions of your NAF PAF as it comes out over the operation, over the life of mine. Again, equipment hours, you can see what impact it's having on your trucks, on your excavators. Make sure that's all looks good. So yeah, so that was sort of a basic one, rough proportions on a dump, landform sort of been set up, and just sort of at a higher level, understand what your NAF PAF issues are going to be longer term and impact on the haulage fleet. Case 2, a little bit more level of detail in this one. So just a couple of X-pit dumps with concept level encapsulation designs. Waste types divided into 3 categories in the model. They were defined by lithology. We've got a NAP limit now on the global dump, so managing how much potential acid it can generate. There's no stockpiling capacity, but still we've got the integrated haulage. So Joe touched on before, having the right level of detail and the right level of plan. There's no use having, everything in the plan if it's just going to slow it down and it's not really going to change your decision. So this is sort of an example here where they had some concept level designs with sort of PAF cells or outer encapsulation, but really what it came down to was just proportions. The dumps are getting built with multiple lifts a year, so you can sort of just have a look at what are the percentages of materials. So we sort of simplified it. So the bottom lifts here are just good limestone with good geochem and good geotechnical capabilities. And then as you go up the dump, you can start to put more of your deleterious sort of materials and not maybe as good geotechnically. So you can sort of change those proportions. To do this, we needed to bring the dumps in lift by lift as separate stages. So the decision tree starts getting quite big, but it gives you that control over each lift. Modelling considerations are very similar to before. Need to sort of make sure you've binned up the material appropriately. You need to start splitting your waste streams into different dumps and lifts, creating some constraints, whether it's for proportion of materials or sort of the NAP, which you can blend for, and some downstream processes to build and set up your truck hours. So for this one, the constraints is the dump precedences are bottom up, dump category proportion limit by lift, and a NAP limit. So here's the decision tree. So it's just sort of starting to grow a little bit, but we've got all the separate dumps. So dump 1 and dump 2, and then we've got all the separate stages, so we can assign attributes here. So Cat 2, Cat 3, or NAP on the global, as well as all the truck hours underneath. Apologies for this table, but what it's sort of trying to highlight here is you've got your attribute constraint, and then you've got your actual. So the highlighted yellow is what you've actually hit, and then the other one is what the limit was. So we can see here as we're starting to construct the dump, we're saying basically nothing but limestone can go to this dump and it can hit it. There's a few little sub-stages, so that's why it sort of jumps around a bit. And then we get to all right, you can send 40% of non-limestone material. And you can see there it's, sometimes it's 0, sometimes it's 2. But you can sort of see this as it's scheduling. You can see the constraints that it's adhering to, and you can see the impact that it's having on the schedule. Global NAP constraints, we had a couple of other dumps here, but you can see here it's sort of bouncing around underneath the limit that we've set, and you can see how constraining these particular limits are. So for this site, we had no stockpile, so we had to source limestone from around the pit. And so to hit all those constraints, this is sort of the impact on that extra limestone material that had to be mined. So it's not just extra truck hours, it's extra drill and blast shovels to get that material out of the ground and onto the dump where it needs to be. And then we can have a look at the haulage. So the red line was the trucks that they had currently purchased and the forecast out over the life of mine. So we can see here we can do all this stuff. We can hit all the dump constraints with the existing fleet. Or we could put in some capital decisions to see how many extra trucks we need. But it's all integrated, so we can go forward with the strategic plan, confidently hand it over to the site planning team to say, look, here's the strategy, and then they've got half a chance of meeting these constraints in their tactical schedule. All right, and finally, so case study 3, very mature operation, lots of geochemical data. The rock constraint, the rock characteristics are well defined. They're in the block model. They've got a very detailed waste dump design, which we've got a cross section of there that has sort of a cover system. So we've got the base, got the core for the nastier PAF, a blended zone for a mix of less nasty PAF and NAF, and then a cover system. And they also had a stockpile. So the trick with this one was to bring in that waste dump, assign the materials to certain sectors, and then have all the constraints. So the dump is actually built in a way that, you're not building over any air, basically. So less on the attributes, this one. It's more on the physical and spatial limitations. So modelling constraints, again, you've got to separate your waste types for the reblocking. Split your waste into separate materials in the process mapping. Still got the downstream dumps to manage the builds. And then on the constraints, a bit more level of detail in how you might build your dump directions and then the precedences around that. Waste decision tree, so a little bit of a change. So it's more material driven with the separate dumps underneath that. So you'll notice the limestone NAF can basically go to any of the sectors, and then the other materials are more limited to what sectors they can go to. For the dump, for something like this, we've got sort of the overall cover, and it's by the design, and we've sort of dissected it by lift, but we'll also dissect it into panels just to give a bit more flexibility for the haulage for short and long haul, as well as a bit more flexibility for how the dump's going to be built. And then we can use the lead lags to manage any location to location precedences. So this is bolted onto the mining schedule with all the processing, so we can start to understand the impact on the operation if we need to put the dump into some sort of a waste dump like this. So as it's scheduling, we're sort of constructing the base. The next year we've got a bit of a blended zone. The path core gets hammered, so it gets built really quickly. On the southern side, we had some restrictions on clearing and some infrastructure that needed to be moved, so you can put a constraint on that, so you can avoid that for a couple of years. Continue building the dump, and you can sort of see the outer cover system is coming up over the top of the blended zone. And then we sort of finish the northern side, and we can start filling in the southern side. So that's sort of the visualizer tied to the schedule. So you also see the pit being mined, but it's just a nice visual tool to see how it all comes together. Now, still on an annual schedule, there's got some detail to worked out for the site planners, but at least at a high level, strategic planning level, you've got a schedule that can deliver the materials at the right time. You can understand the impact on the trucks. You can see where the different materials are going to go. And for this one, we needed quite a large NAF stockpile. So that then triggers, all right, where's it going to go? Do we need extra clearing? Do we need extra permits? You can start asking those questions from day one rather than trying to react to it later in the mine life. So as you've seen, MineMax gives you the flexibility to model virtual any waste dump configuration with a level of detail tailored to your project needs. It's not just about design, it's about integrating landform ARD constraints and haulage seamlessly into one plan. So why wait for problems to arise later when you can deal with them now and avoid that hassle? So thanks for your time.